In this video, I will go over two classes that are derived from class Irish, and I will show how we implement the rules that I've just described with inheritance and polymorphism in order to be able to successfully implement the inheritance hierarchy. The first class is class student. So before I even get into the class, I want to point out that I'm revisiting this enumerated type that's class, and this just basically is translated 0, 1, 2, and 3. So anywhere we see uppercase senior, this enumerated type is very similar to a pound-defined directive. So anywhere you see senior, it just replaces it with 3. We see here that I have class student. And therefore, in order to inherit from Irish, I put a colon and then public Irish. If this were templated, if Irish was Irish T, I would actually have to say to Irish T here. But that would also mean that we have a template class T, which also we'd have to put this here. And the reason why we have to do this is because this is our way of letting C++ know that we need to create a class Irish and that the private members that are dependent upon this template would fill in here, which means when it puts everything onto the data heap, we know precisely how much data and space and memory we need to be able to allocate. But that's not what we're going to do. Irish is not a templated class. So since we have it as public, everything from irish.h that is protected is now also a member of student. So student now has its own unique private members, class and standard string. We also have a private method getClass, which returns a string, and I'll show you that in a moment. In the constructor, in .h, I just have all the information, last, first, NDID, and class in. And then I have the destructor here. Remember in the rules that I mentioned that the derived classes are not to be labeled as virtual. That is, unless student were to be the base class for another set of derived classes. For example, if I went back to video 1, I wanted to create an undergraduate or graduate objects, then I would need to make this virtual. I also want you to notice that you cannot do polymorphism on friend operators. I have a student, the student here, and I have to print out all the members. I cannot inherit from Irish. This is something that you will need to do in your Coding Challenge 6 when you're dealing with both the double hash and the quadratic probe. In student.cpp, we have our constructor here. And remember the rule that I said that when you have a base class, Irish, that is of which student derives from, you have to call that base constructors first. And the reason why is when we allocate it on the data heap, we have the this pointer. The this pointer is initially going to put all the protected members from Irish, and then in the next location, it's going to put all of the private members of student. And so last, first, and NDID go here, then stu class, and then dorm. I'm also printing out base address of student object. If you recall from the previous video, I did the same thing in irish.cpp here in its constructor as well. So we're going to see how C++ allocates student and Irish on the heap. You see I have the destructor here, and all I'm doing, since we don't have a private member that's a pointer, I'm just destroying the derived class student. getClass is that private method from student.h, and what it's doing is it runs a switch statement on stu_class. Stu_class is the private member of that enumerated type. So freshman, it's actually case 0, or it's case 1, junior, case 2, and it's returning a word that can be read by the user. So set dorms, normal, operator. The operator is accessing everything in the way that we normally would. So now let's go to print information. So this is the last rule that I was describing, and I want to show you the difference between what we need to access as private members of the base class, protected members of the base class, and private members of the derived class. Because you will need to be able to do this in your coding challenge for both the actual, for both the double hash and the quadratic probe. For the protected members, you have to use this and then the last name. So that way it knows, so if we have the protected and then private, it knows to go here first before going here. So all this is basically ensuring that you're doing proper pointer arithmetic. And C++, by forcing us to do this, is ensuring that we do it correctly and that it abstracts the complexity away. So we see that for the non-protected members, which are the private members of student, we can go get class and then dorm. We don't need to do this in order to access those. Although, sorry, never mind, not even that. So if we do faculty, I have another enumerated type, and it goes through the same process. I'm doing the same things. Again, notice how I have void print information. And in student, I had the same thing, void print information. I was able to do that with the same names because in irish.h, I have a virtual void print information. So I'm able to do many forms of this depending on the object from the inherited type. And that is the example of what is known as polymorphism. In faculty.cpp, it's very similar. For the constructor, I print the address of the faculty object. And then when I destroy it, I'd indicate that I'm destroying the faculty object. And then in print information, I do the same thing. I use the this keyword to access the derived members from the base class, from the protected. And then since these are private members of faculty, I do not need to use the this keyword. Again, I have to write a new version of faculty's overloaded operator. I cannot inherit that because it's a friend operator. In the first inherit.cpp, what we're going to see is I have 2 students and 2 faculty, and we're going to put those onto the data heap. Then I'm going to set their addresses. Then I'll set the department for the faculty and the dorm for students. And then I'm going to use the overloaded operator to print out the information. Then we're going to see that C++ abstractly deletes the information from the data heap. And so we'll be able to see the actual addresses when I run make inherit here. So when I run this compilation, you're going to see a very large, before you even get to anything else, you see that in the make file, when I'm running everything, it's compiling several objects together. This is one of the benefits of using make files, because otherwise we'd have to type out all of these commands. So as you get into larger and larger projects like you might encounter in industry, this process that we're using, that we've introduced all the way back when we did Hello World, will now become of benefit to you. So now the next thing I would like to do is I'd like to show you how they are all allocated on the data heap. So first we see that I have created an Irish object, and then it says base address of student object. So let's take a look at the .cpp file, and we see that the first thing I do is I create a student. And if we look at what's printed out here, I want you to note that these two print out the exact same address. So what happens is it constructs the Irish object and then constructs the student on top of it, but they're both pointing at the same location, which means what's actually going on is we are allocating the protected members first, and then we are allocating the private members. This is why one of the rules is that the very first thing you should do in the member initialization list is call the base class constructor. We see we have the same thing with faculty. Notice that this is the first faculty object and they're the exact same address. Then we have another student and another faculty. Again, they're the same address. We use the overloaded operator to print everything out, and then we see that we call the destructors, that it destructs the derived object first faculty and then the base class. We see that this is 860, so just like with everything else, we notice that with 860, it's deleting the last object we created first, and it deletes them in the opposite order. So it creates the base class and then creates the derived class on top of it, and then it deletes the derived class and then deletes the base class and performs all of this. The last thing I would like to show you is inherit2. Inherit2 does all the same stuff, but instead of using the overloaded operator, we use the polymorphic print information method. To review, if I go to faculty.cpp, the crucial thing I want you to learn from this is that we are implementing the this keyword to access the protected members that are derived from the base class or the protected methods. In Coding Challenge 6, when you write your find position method, particularly for double hash, you're going to have a second hash function that you've written that will be a private method of the double hash. But in order to access the first hash function, that is a protected method from the base class of hashtable. So therefore, you need to know when to use this and when not to use this in order to make it effective. So we run the same thing. I run make clean, clear, and I run make inherit2. And again, we see the exact same process. It's constructing the objects in the exact same way. It prints everything out and then destructs all the objects in the exact same order.